Very good evening, friends. Myself, Anshu Srivastav. Welcome to Never Stop Learning channel. Today, we are going to start one topic that is electrical generator. But before starting this topic, I'm really thankful for all the viewers who are watching my channels and give a nice feedback on all my contents, what I have posted on YouTube channel. Thank you so much. Please comment and give a feedback to us so that we are ready to share you others important and informative contents to you which is essential for your life. So we have to go for electrical generator. This is for electrical engineering students or the electrical peoples who are doing the job in the company, and there are many important peoples who have daily interactions with this generator, how to manage the generator. Viewers, as you know that this generator is very important for us because in our surrounding, if we see anywhere, generator plays an important role in all the institutions, in all the societies, in every area. And why we use the generator? The generator is the backup of electricity. If there is no electricity in your society or in your office, then generator gives the electrical energy and performed as a backup of the main electricity. So let's recap on electrical generator, what exactly it is and what is the technology behind that. Now the first slide, if you see, how does a generator works? First of all, you remember that the generator, it has a armature inside, and there is a outer shell which covers that armature, and whenever you rotate the armature by any pedal, so rotating the armature is called mechanical energy you have applied, and then it converts into electrical energy. So as a simple definition, you have to know that electric generator works by converting mechanical energy into electrical energy. It operates based on the electromagnetic inductions principles, which is the creation of an electric current by moving a wire next to a magnet. Okay, so if you see this design, let me enlarge this design. Now you can see the concept behind that. Let's we talk about the electromagnetic inductions. Everybody knows the magnet, right? So magnet, it has two ends, north and south poles, and the magnetic lines of force generate from north pole and it reaches to south poles. And this magnet, the wire is wound on that magnet, if you see. So here it is mentioned clearly, if you see here, that a magnet moves into and out of the coil, generating a magnetic field opposite the motion, and induce alternating and voltages generator. Okay, so we have to understand what is the concept behind that, but now it is clear that the generator mechanism, the electromagnetic inductions is performed. Now, the Faraday law of electromagnetic inductions. So let's we zoom this diagram first, understand what exactly it is. You just see the armature is at the center, and armature is connected with this shaft, and the outer shell of this generator is covered with poles, your north and south poles. Okay, and what I have just explained to you earlier, that we have to rotate the armature. Okay, so let's come to the definition of Faraday law of electromagnetic inductions. The process of producing an electric current in a conductor by changing magnetic field, either by moving the conductor through the stationary magnetic field or by changing the magnetic field around the stationary conductor. This phenomena creates an electromagnetic force EMF or the voltage across the conductor and is the fundamental principles behind electric generator, transformers and motors. So I hope it is very clear to you that we have the armature in a generator and magnetic field is also there. Only one part should be rotate, either your magnetic field or your armature. Then what happens? It cuts the magnetic lines of force which creates the current and induced EMF. Now just go through the parts of generator. So I guess that those who are electrical engineer, or those who are daily interact with the electrical technology, they are familiar with this concept of the parts of generator. Now the armature is this, just see, and there is a shaft, bearing is also there, and bracket is there, frame is the outer body of this generator, stator is there, commutator and brush assembly. So these are the parts which is essential to construct the generator. Now let me just go through this section, overview section. This is the same thing, but here if you see, the yoke is a frame. Okay, pole is there, north south poles, but here four poles are using, two are north and two are south. Field winding is there. Now you just see that the wire is also wound on the magnet. This is a field winding, and there is also wire which is wounded on the armature inside. Okay, so armature conductors, brushes, commutator, and the last one is your terminal box. Okay, I hope at this level it is cleared to you. Sorry. Now let's we talk about the right hand thumb rule or it is also called the Fleming right hand rule. So if you see the diagram, just the thumb is your force or motion, the middle fingers denotes the magnetic field, and the another finger denotes your current. So this rule is applicable to the generator only, used to determine the directions of the induced current. This rule says that your right hand, if you stretched your thumb, the first finger and the second finger perpendicular to each other, and if you align your right hand thumb along the direction of motion of the conductor in the magnetic field, and first finger along the direction of magnetic field, then you you second finger indicates the direction of EMF in the conductor. So this exactly it is just to denote the direction of current, the direction of your force or motion, okay, and the magnetic fields. Now let's we compare with this rule with generator design. Now let me zoom this one. It is clear to you. See, the north and south poles are there. Magnetic lines are travels from north pole to south poles, and between that there is a armature. Okay, there is a normal conductor, and if we apply this right hand thumb rule, so the direction of the force is upwards here. Okay, and the direction of magnetic field, which is from north to south pole, and the direction of current according to thumb rule, you can see from where it is flowing. Okay, so this is the concept we know in a generator. Now just come to this section. This is the same thing. Okay, let me enlarge this one. Sorry. So just check here, permanent magnets are there, north and south poles. There is a rectangle coil is there. Okay, and here the shaft rotates in the anti-clockwise directions, and after that slip rings your brushes, okay, which is uh, relevant to connect the galvanometer. Okay, carbon brush I'm talking about, commutator is there. So this is how we close the circuit, how we get the induced current as well as the induced EMF across this armature. Let's we talk about the induced EMF of a DC generator, electromagnetic force EMF. So I think it is clear to you. So induced EMF in one conductor and induced EMF of the generator. Let's we talk about how much induced EMF we will get in a conductor. So induced EMF of one conductor, now for one revolution of the conductor, let's phi is the flux produced by each pole in Weber. P is the number of poles in the DC generator. Therefore, the total flux produced by all the poles is equal to phi into P. Time taken to complete one revolution equal to 60 upon N. Consider as the speed of the armature conductor measured in revolutions per minute RPM. According to Faraday law of electromagnetic inductions, the induced EMF of the armature conductor is denoted by E, which is equal to the rate of cutting flux. So E is equals to change of flux with respect to change of time. So E is equals to total flux upon time taken. Now induced EMF in one conductor, just put the values of flux phi P. Okay, total flux is your phi and P, and the time taken is 60 upon N. So you will get phi P and upon 60. This is the induced EMF in one conductor. Now we will talk about the induced EMF of the armature of DC generator. So only we just multiply by Z. Z is the total number of armature conductors in the armature. So we multiply by this. Now let we just explain once again. Eg is the generated EMF in volts. Phi is the magnetic flux per pole in Weber. P is the number of poles of the generator. N is the speed of armature in revolutions per minute in RPM. Z is the total number of armature conductors, and A is the number of parallel paths of the armature winding. So one more thing, that also A is the number of parallel paths in the armature windings. How many parallel paths are there in that armature winding? That is denoted by A, and it is mentioned in that equations. Let's have a look of key learning what we gained today. Generator working principles. An electric generator works by moving a conductor through the magnetic field, inducing an electromagnetic force EMF based on Faraday law of electromagnetic induction. The Fleming right-hand rule. This rule determines the direction of EMF using thumb rule for motion, the first finger for magnetic field, and the second finger for EMF direction. The AC versus DC generator. The AC generator use slip ring to maintain the alternating nature of generated current, whereas the DC generator use a commutator to rectify the current. Single loop generator models, the simplest form of electric generator, where rotating a conductor loop between the magnetic poles alters the direction of induced EMF. Energy conversion. Electric generator converts mechanical energy into electrical energy, crucial for various applications from household to industrial uses. Thank you for watching my channel. Viewers, please like this channel and put your comment so that we will upload more uh, contents for this channel. If you have any doubt, so please get back to me. Thank you very much. Have a good day. Bye.